We're going to go through the valve bank adjustments and settings on the valve bank of the Bale bearing, and some valves to adjust in case of a service call. We're going to detail the Nodder flow control. We're going to go through the load sense setup. We're going to go through the plunger regen valve. We're going to go through the injector sequencing valve, where to put the pressure gauge on, and the table flow control that controls the table speed. And then I'm going to talk about switching out one valve for another in case you have an issue with one valve and you want to see in the field when it comes to service. First, we're going to talk about the Nodder flow control. The correct setting for the Nodder flow control is all the way open, so that'd be counterclockwise, out all the way or up all the way. And that regulates the flow to the Nodder at 32 rounds per minute. If you need to slow the Nodder down for diagnostic reasons, to bring the needles up nice and slow to see if they're set up right, or check out other settings, you can close this valve all the way, engage the Nodder, slowly open the valve until the needles start to move forward nice and slowly, and just regulate the flow that way. But again, the correct setting is all the way open, and that is 32 rounds per minute. So I just crank it out all the way, and then this nut down below is a locking nut, and it keeps a Nodder from adjusting on its own. This is load sense bypass adjustment screw. Generally, we run them all the way closed. If you loosen off the jam nut, turn them in until they're snug, tighten up the jam nut again. But depending on what system you're on, you're going to have to open that maybe a quarter of a turn. I'll get into that on the load sense bypass adjustment video later on. Thirdly, we're going to talk about the plunger regen valve. If the correct setting for this valve is counterclockwise all the way, so if you loosen off this jam nut and turn this valve counterclockwise the entire way until it's snug, that's the right setting. The plunger regen valve takes the oil from the rod side of the cylinder and puts oil into the barrel side of the cylinder on its way in, so on its compression stroke. And that's only if there's little to no load on the plunger. As soon as there's a load, so when we're compressing the bundle, then that disengages and we only take oil from the pump instead of recirculating the oil. So if you did have an issue where this valve is malfunctioning, you could choose to turn this adjustment screw clockwise the entire way, and that would disengage that regeneration mode. It would slow the plunger down, but it would allow you to keep baling. Next adjustment is the injector sequencing valve, and it controls how fast the stage 2 cylinder extends as the stage 1 cylinder is going back towards the back of the machine. If it's open too far, the stage 2 cylinder will extend too soon, and it can cause bales to roll or jam. So we'll get into a video detailing on how to set that later on. The table flow control is this adjustment down here at the bottom. The table is correct at 12 rounds per minute. If you have the table going too fast, you can run into the bales catching in the injector area and pinching off. So just draw a line on the table and time it with a stopwatch to make sure it's going 12 rounds per minute. Turning the adjustment screw in towards the center of the valve manifold will slow the table down, or counterclockwise will speed the table up. The pressure gauge adapter port is this right here. There's a dust cover on it. Leave the dust cover on it unless you have the pressure gauge on. Pressure gauge is located in the spare parts kit on the opposite side of the machine, and it just threads onto this pressure gauge adapter port like this. The reason why we have this so easily removable is because the pressure is constantly going up and down, so the needle is constantly moving up and down. We'll ruin the gauges if we leave them on because of all that pressure surging. So it is not recommended to leave this pressure gauge on, but only to use the pressure gauge for diagnostic reasons. So if you had to figure out what kind of pressure you were running on the Bale bearing, you would just install the pressure gauge, start your tractor, and you could tell what operating pressures you had in that regard. Next, we were going to talk about if you had a service issue with a valve. I'll just, for example, if our plunger wasn't operating correctly, plunger is described on the valve bank here, indicating that this valve is what operates the plunger. If the plunger was all the way in and it wasn't coming out, but we still could move the end gates or move the injector back. We would be able to switch one valve for another. The way these work, this is a double electric solenoid valve, and that sends oil to the pilot operated control valve. So it's a two valve system to operate one function. If we were suspicious that it was a valve that was causing the problem, we could choose to switch this electric solenoid valve for the end gate electric solenoid valve simply by removing the lock nut that holds the solenoids onto the valve. Removing the solenoids, this valve threads into the valve body. Remove that valve, do the same for the end gate and switch them out and reassemble everything, and then see if your problem moves to the end gates or if it's resolved on the plunger. Secondly, what you can do is remove the the pilot operated control valve, and that's this big guy back here. And I'll just do this to show you how this valve looks. It's an 1.5 wrench. If we just loosen it off, thread it out of the valve body. And there will be a bunch of oil that spills out, so it's good to have a catch basin for it. But if we pull this valve out of the body, I'll just explain how this valve is. There's 4 sets of seal kits on this valve, and then there's the main sealing valve, or the main sealing O-ring to contain the oil into the valve bank, as well as some backup seals. So I always inspect to make sure the seals are all there and accounted for, and there's no irregularities on the seals. We've got a white plastic back, I don't know what to call it, but a white plastic seal, and then an O-ring, and then another white plastic seal on each and every set of seals. So just inspect them, take a good look at them, and then look for any contamination stuck in the cross ports on this valve. If let's say a seal on a cylinder blew apart, or if some outside contamination come in through the couplers and got into the system, and it got caught in one of these ports, it would restrict the valve from moving both ways, and that could be the cause of the plunger not moving. So we take a good look at it. We don't see any irregularities. Next, we would choose to remove this valve, replace it into this port, and then replace this valve into the port down here, tighten everything back up, and see if our problem is moved or resolved. If the problem's moved, then we would either replace this valve or just clean the contamination out of it. It's a judgment call you make at the time, and reassemble it, torque it up to roughly 70 foot-pounds. If you don't have a torque wrench on your person, generally you might not out in the field, just get on it with a wrench and make sure you're good and snug. You don't want it loose. If it threads loose, the seals will blow. Same goes for the injector circuit. It can be swapped out with either the plunger or the end gate circuit. Either the double solenoid valves can be exchanged, or the pilot operated control valves.